In this lesson, you will factor trinomials in the form ax squared plus bx plus c. So you'll notice the difference is now we have a number in the very front. And we'll also be able to solve equations, and I'll give you the steps to form those equations. So see how this trinomial differs? Last week you were using just the x squared term in front, but now we have a number in front. And what you would do is the same thing that you've been doing all along. You're finding the product and you're finding the sum. But there is a difference. Because we have a number in front, we have to now find a product of the first two together. So we're going to take 3 times 2, which would give us 6. And we're looking for a middle term of 5. So your two numbers that would give you a product of 6 and a sum of 5 are going to be 2 and 3. 2 times 3 would do that. Now here's what the book is going to tell you to do. The book is going to tell you to do 2x squared plus, and then write these in order, 2x plus 3x plus last term 3, and then do the factoring by grouping, where you factor something out in front, factor something out in front, and that's what the book's going to tell you to do. And if you want me to work that with you, I can. But I have a shortcut for you, and this is the shortcut. What you're going to do is the same thing that we've done before, product and then sum, but you're going to rewrite it in your binomial forms with this 2 in front. So you'd have 2x plus 2 and 2x plus 3. Now this does not have a common factor, 2 and 3, so this is definitely one of our solutions. This has a common factor of 2, so you just divide those out by 2 and you get x plus 1. So these are our binomials, x plus 1 and 2x plus 3. Now if you would have done the factoring by grouping, this is what you would have found. So what I want you to do is to practice the shortcut, and if you're struggling with the shortcut, you could definitely practice it more and get better, or you can let me know and I can walk you through the factoring by grouping, or I do have another shortcut I can show you if you're really struggling with this one. So let's try the shortcut again. So first term times last. So we're looking for a product of 28 that would give us a sum of middle term, which is 29. So would you agree that that's 28 and 1? So if we're doing the AC method, we are going to keep that first number in front, so that's going to be 7x plus 28, and we have 7x plus 1. These do not factor, so this is one of our solutions for sure. These we can divide both by 7, right? So we have x plus 4 times 7x plus 1, and then these are our two binomials. One more example before you practice in your notes. If you'll notice, these 3 terms in this trinomial have a common factor. In fact, I can divide all of these by 2. So let's go ahead and do that. And now it's a little more simplified. So we have 3x squared plus 11x minus 4. Now our numbers are smaller. They're going to be easier to multiply and find factors of. So we're looking for a times c here, a product of negative 12 that would give you a sum of a positive 11. Well, if you think about, one of them has to be negative, and we want this positive result, so the larger number will have to be the positive number. And if you think about 12 and negative 1, that would give you a negative 12, and 12 minus 1 is 11. We do have to keep this term out front, so we have 3x plus 12 and 3x minus 1. Well, we know this is simplified, so this will stay. These I can divide out of 3. So this becomes x plus 4 times 3x minus 1. Now if you wanted to check this, you could definitely do your FOIL or do your boxes to check it. What we have to do now is put that 2 that we factored out at the beginning out front. Because remember, when we divide by something or factor it out, it doesn't go away. It has to be there, but we don't have to put it in until the very end where we have our binomials. So you try the examples in your notes. Now, what happens when I have a common factor going all the way across? In this case, these are all relatively prime. We don't have a factor to share. So you would just factor that with the A times C method, and you're going to look for a product of 60 that would give you a sum of negative 17. So you're looking for 2 numbers that are both negative, and so that would be your negative 12 and your negative 5, and negative 12 and negative 5. So when we factor, we keep that 3 out front, so it's 3x minus 12 and 3x minus 5. Well, these do not divide, so it's going to stay, but these I can divide by 3, so that would be x minus 4 times 3x minus 5. This is completely factored, and if you wanted to check, you could FOIL it if you wanted to. Here, what common factor do we have? Well, all of these do divide by 5. So since they all divide by 5, I would have 2x squared minus 7x plus 6. This is going to be much easier to factor, looking for a product of 12, 6 times 2, that would give you a sum of negative 7. So since I have a negative sum, they have to both be negative numbers, and I think in this situation, negative 4 and negative 3 would do this for us because these would be a positive 12, and when you add those together, you get a negative 7. So put that 2 in front, so we have 2x minus 4, 2x minus 3. Now these would not factor, so we know this is one of our solutions, but we can divide both of these by 2, and that would give us x minus 2. Now remember here, I factored out that 5 at the beginning, so I have to put that 5 out front to say what I divided from in the very beginning. So you try the example in your notes. A prime polynomial is a polynomial that cannot be written as a product of two polynomials with integral coefficients. What that means is you're going to start your AC method and look for factors of 20 that would give you a sum of negative 3. Well, there are none. If you look at the factors of 20, 1 and 20, 2 and 10, 4 and 5, and that's it. These are all the factors of 20, nothing else. And if you wanted a sum of negative 3, none of these would do that for you. So this is what we would call a prime polynomial because there is nothing that you can multiply that would give you that particular sum. And I'll tell you on the assignment how many primes you're going to have because it's good to know how many primes you have before you start. Sometimes there are factors that are hard to find, and I don't want you to take the easy way out and say it's prime when you can find the factors. So try the example of a prime polynomial in your notes. What I'm going to have you work on, and we'll talk about it in class tomorrow, is a real-life example of factoring. So suppose a cheetah pouncing on an antelope leaps with an initial upward velocity of 19 feet per second. How long is the cheetah in the air if it lands on the antelope's hindquarters 3 feet from the ground? What I'm going to give you is an equation that you can start and plug some values in, and then we'll see if you can get the right result when we work in class tomorrow.